Hello friends, good morning to all. So last two lectures we have seen this partial differentiation. We have started from introduction of your differentiation. Then we have seen the definition of partial differentiation. Then we are come to the successive differentiation. And last lecture we have seen your total differentiation including your tangent approximation. So please remember that we are focused toward the physical significance of each and every statement. Okay, so that is very important. So in today's lecture we'll see the exact differentiation. Okay, so before that I will cover one topic and then we'll go to the total differentiation because that is very important. One statement is the function and its derivative, the function and its derivatives, okay, derivatives are continuous then we can write the second partial derivative are commutative. Okay, so this is d by x by d by y, which is equal to d by 2f by d by y and d by x. Okay, so this probably you have seen in mathematics. The function and its derivatives are continuous. Continuous means it is related to your limit. Okay, so any function is there and its derivative, it should be a continuous, then and then we can write this particular thing. Okay, so before this we'll understood what do you mean by function and its derivative is continuous. Okay, so I will take a small example so you will understood what I want to say here. Now this is your function. Okay, so this is x. I will take only one dimensional case. So this is f of x and the given function is just like this one. And second graph I will draw here. Okay, so in this case I will write this is one case and this is your another case. So here this is A and this is your B. Here is also this is A. Suppose this is your C and something is related to your C, B. Okay, and this is your x and this is your f(x). So in this case what we will observe, the given, this is just like sinusoidal function, so the function is continuously change. Okay, but the given function is smooth one. Okay, the function is smooth, so there is no abrupt change in that particular function. So as you varies from point A to B, okay, the slope is continuously changing, it is coming over here and you will get a smooth thing. So such a function we call as your continuous function. Okay, such function is called as your continuous function. Whereas in this case if you see the function it changes from A to C, okay, and A to C, so it is constant function. But when your function your C to B, that time it is abruptly change, okay, from here to here and then it will be changed. So such a function is called as your discontinuous function. Discontinuous function. So that part we have to remember over here. I will take one small example. What do you mean by your continuous and its derivative is continuous. So probably you will understood the function is smooth, so there is no break in between them. Don't consider this is at C point, this both are at a C, but see the f of x probably here is 2 and here might be your 4, so these two are not same. Okay, so we require the given function and its derivative, just like f dash x, f double dash x, or you can take x and y also. So that should be your continuous. Okay, so simple example I will take here and you will understood what we want to say here. Okay, so first I will take example is what, this is f of x, suppose, which is a function of, this is x square minus 3, where x is less than 2. Okay, and this is 4x minus your 7, so that is nothing but x is greater than or equal to 2. Now continuity we have to see first. Okay, so what I will take, x is less than 2. X is less than 2 means limit x less than 2. So this is 2 minus f of x, suppose I will put here, so that is nothing but what, this is 2 square minus 3, you will get the answer is 1, 4 minus 3 is 1. Then I will again take, suppose limit positive x is greater than 2, first I will take, so this is 2 positive, so that function f of x, so what is, this is 4 and here is 2 minus 7, 8 minus 7 is 1. Now see, here is also 1, here is also 1, means you will get a constant thing over here. Now we want to check at x equal to 2. Okay, so this is limit at x tends to 2. Here this is for negative, this is for positive, and this is for 2. See the condition, conditions are very very important. So f of x, and what is the value, this is 4, 2 minus 7, and that is also 1. So what we can say from this one, the given function is continuous. Now my aim is what, my first derivative should be continuous. Okay, so what I will take, I will take, suppose this is f dash of x. F dash of x is nothing but what, the partial derivative with respect to the x. So this is your twice x minus 3. What limit, x is less than 2. Then f double dash at this point, so 4 only, so x is greater than or equal to 2. Again I will take a limit for this particular case, because I want to show that the value should be continuous. Okay, so this is nothing but limit x tends to 2 minus, and that will gives f dash of this x, this is nothing but 2 into 2 minus 3, that will gives a value how much, so sorry, here is only, this derivative is only twice x, so this is nothing but your 4, and limit, this is 2 positive. Okay, so that is your twice of positive, you have dash of x, which is nothing but how much, this is 4. Again we have to check at equal condition, so that will gives f of x limit x equal to 2 f dash of x, which is also 4. Okay, now see, this is also continuous, means constant value of their derivative, and when you are taken limit, so limit is same for all the condition, x is less than 2, greater than 2, equal to 2, so 4, 4, 4, so we can say continuous. Suppose here the limit is not continuous, means what, these values are different. So suppose here you will get one value, here you will get something different, just like two values. So in that case the given limit is not continuous, limit is not continuous, then there is no point. Okay, so the important point is what, the function and its derivative should be continuous, means we have taken the limit of the given function as well as the limit of its derivative, and I will get a continuity. So in graph point of view, how we can draw this particular function, suppose this is f of x function, x minus 3, so the curve it is just like this one probably, Okay. Now 4x minus 7, the curve is just like your it is passing through that one, so it is here. When you combine both the curve, this is belong to this one, this belong to this one. Okay, so when we combine both the things, the function, so that time I will get what? This is x is equal to, so here, so it is going just. So please remember, this is your function. Both the case we have drawn. Huh? This is x equal to 2. So below this particular, you will get x is less than 2. You will get such curve, and here. So this is your x, this is your fx. Now at the point x is equal to 2, okay, and if you want to plot a slope of this line, now see, this is your straight line. There is no discontinuity in the given function. Discontinuity is not given in a function, and slope you will get constant, means the fx and f dash of x is continuous, means the function and its derivatives are continuous, means their limit is exist, and basically the derivative is indicate the continuity of that particular function. So you can go to the higher derivatives also. So conclusion is what? The function and its derivative should be continuous, then we can write f dash of 2, suppose this one, which is equal to f dash this one, which is equal to this. Okay, now we'll prepare for your exact differential equation, because we require the continuity of that function as well as their partial derivative, means first order, second order, third order, whatever that. Okay, so these things are important. Now my topic is what? Exact differential equation. Okay, so in exact differential probably you are learning calculus also. So in calculus one theorem is there, and the theorem is what? The necessary and sufficient condition for the differential equation m dx plus your n dy is equal to 0 to be exact, is dabba m by dabba y is equal to dabba n by dabba x. So this is the condition for exactness. What is the condition? This theorem you have probably learned in calculus. So we'll see briefly what they want to say here. So the necessary and sufficient condition for the differential equation to be exact is dabba m by dabba y is equal to dabba n by dabba x. So this is the case we will have to consider over here. Now what is the meaning of this one? How we can write? Because we know our function is what? Function f of x, which is nothing but what? Suppose this is one particular function, okay, which is depend on two variable. So suppose I am to write a df of such function, okay, total differentiation with respect to your x as well as y. So we can write dabba f by dabba x into your dx plus dabba f by dabba y into your dy. Okay, So this is my total differentiation with respect to the x and y. Okay, but in this case, this is what? This is your m, this is your n, but this is equal to your 0. This is equal to 0 means differential is 0. Differential is 0 means what? The function should be constant. Then and then we can write a differential f is 0. This is belong to what? Your function f of x is equal to. So suppose I will consider the given function is your exact. I will see small proof of this one. The exact function suppose. Okay. So in an exact function we can write df is equal to dou by f by dou by x dx plus dou by f by dou by y into dy, which is nothing but your m dx plus your n dy. Okay. So from this, compare the coefficient of dx and this one, so we can write this particular comparison. So m is equal to dou by f by dou by x, and we can write n equal to dou by f by dou by y. Okay. Now we'll assume that this is m. The second order partial derivatives are continuous. That's why we have taken that particular topic. What we'll assume, my aim is we have to prove this suppose. So the second order partial derivative with respect to this function is continuous. So what I'll write, the given function dou by m, because we have to see. So m with respect to the y. So y. So this is equal to, which is nothing but dou by 2f by dou by x dou by y suppose. Okay, or we can write this is dou by y dou by x. Okay. Now this is with respect to the n. We have taken the function is exact one. So that is similar to dou by 2f by dou by x dou by y with respect to the n. So this will give dou by n by dou by x. So we are assuming that what? This is the function f which is depend on two variable x and y. We have taken the total differentiation and that is equal to m dx plus. Just we have compared the coefficient of dx and dy, we will get m and n, and we are assuming that their second order derivative of this function is also continuous, then dou by m by dou by y, which is nothing but. So that we have seen. So from this we will get this particular case. Okay. Now from this, suppose we have, so here condition what we have taken, this is. Now let us assume that another function, suppose g is a function of your x and y. Okay. And this function g is a function of your x and y. Now my aim is what? We have taken initially its necessary condition and then we have to go to the sufficient condition. So g is a function of your x and y. So which we can write, this is m integral of m into dx. How we can write this one? So here dou by g by dou by x, which is equal to m. Okay, and here we can write the partial integral, means this, suppose we have taken dou by g is equal to m into dou by x and I want to find out g. So what I will do, I will integrate this one. That's same step is here. So we can write this is partial integral of m such that dou by g by dou by x is equal to your m. Okay. So this is my dou by g by dou by x is equal to my m. Okay. Now next is what? We want to first show that this is n minus dou by g by dou by y into, this is function of only y. Okay. This is function of only y. So n minus dou by g by dou by y, and this is only function. This is free from x. Many times you will use the word is free from x. So how we can show that? Suppose I am to show that this is free from x. So we will partiate this function with respect to the x. Simple thing. So this is deba by deba x, and this is n minus deba g by deba y. So what we can write here? This is deba n by deba x. This is minus deba 2 g by deba x and deba y. Okay. So this is nothing but what we can write for this one. Suppose this is commutative, so deba g by deba x. So this is similar to your 0, because the given function I can write deba n by deba x minus I can write deba m by deba y. Okay. So this is nothing but 0. See here, initially we have proved this one. M is nothing but what? Deba g by deba x. So instead of here, we can put deba g by deba x. So m, and already deba g by deba y. So this is equal to 0, means the given function is free from x. So it is a function of only y. Okay. So this is my first case, and here we have taken assumption of that particular case. Okay. Then what we can write for this one? So this is f is function of, suppose, so this is f is function of your g of x y, sir. Okay. And this is your n is free from y, so n minus deba g by deba y. Suppose we will take a total derivative of the f function, so df is nothing but dg of your x, y and y plus d times n minus deba g by deba y. Okay. Now total derivative of this function is what? With respect to the x and y, so deba g by deba x into dx plus deba g by deba y into your dy minus, okay, so this is a total differentiation with respect, means this is x and y. Okay. So that we can write what? This is plus deba, I will write this particular function with respect to your x. Okay. So this is my term with respect to the x, and this is your x plus n term means what? N minus deba g by deba y. This is, we have taken the total differentiation with respect to the x, and this is deba by deba y. This is n minus deba g by deba y into your dy. Now please remember, this is function of only y, so, and we are partial differentiation, so this is going to straightforward 0. Okay. So this is the case. Now if you are doing this deba g by deba, this particular function, okay, so this is nothing but what? This further step, deba g by deba x into your dx plus deba g by deba y into your dy, and we'll do this particular case. Okay. And that is nothing but what? Deba by deba y into dy. So here I will get only the term. Okay. So that is nothing but n into your dy. Okay, because you are taken n, which is function of your y. So that is nothing but plus n time dy. Okay, minus this particular function, suppose we will take, so that is belong to minus deba g by deba y into your dy. Again this will be cancelled, so what will remaining here? This is deba g by deba x into your dx plus n times your dy. but this is m is equal to what? Dabba g by dabba x. So we can write this is m into your dx plus n times d bar. Okay, so that case we have to consider over here. So this is my df. So we have started from this given function is exact one. So this condition we have start from this particular condition. We have taken g is a function of f of xy, and you will get final function df is equal to m dx plus your n dy. Okay, so this proof you have seen in mathematics, so I will not go into the details. Only you should remember the given function and its one. But please remember, here is 0. Here is 0 means the function should be constant. Function should be constant means whatever we have taken, suppose df is equal to your m dx plus your n dy. So the df should be 0. Df should be 0. Then we can write this is m dx plus your n dy, differential equation. Okay, so exact differential equation. So df is 0. So df is 0 only at one condition. This is f should be constant. F should be constant. Then and then write this is f is constant. The differential of any constant function which is 0, please remember that is also continuous. Okay, and the constant and its differential is 0 means you can write m dx plus n dy equal to that. Okay, so that case you have to consider over here. So this is a case means the solution df equal to 0, df equal to 0, f is constant. Okay, so we'll take one problem. So we'll please remember this is the condition. So overall here you have to remember only the few things. Okay, so that is one, the necessary and sufficient condition for the differential equation m dx plus n dy equal to 0 is to be exact. Dabba m by dabba y is equal to dabba n by dabba x, and where this df is equal to 0, df is equal to 0 means function is constant. So you can find out the given function from the exactness condition also. Okay, so I will take a small problem. So many times they will ask the problem is show that a given function is exact differential and find out the function f. Okay, or sometime check the condition of your exactness. So you have to check dabba m by dabba y is equal to dabba n by dabba x. So here I will take a small problem. The problem is show that this is x square minus your 4xy minus twice y square into your dx plus this is y square minus your 4xy minus twice x square dy. Okay, so this is you want to show that this is the exact differential equation. So df is equal to this function, suppose you have given df is equal to this is 1 m dx plus your n dy, and you want to show that this is an exact differential equation. Okay, and the second is find the f. Okay, so simple. So we know this is df, which is nothing but your m dx. First compare this one m dy. Now when the given function is exact differential equation, when your df equal to 0, okay, so m you will compare with this one. So m is what? This is x square minus your 4xy minus your twice y square, and n equal to y square minus your 4xy minus your twice x square. Now what is the my condition for exactness? Dabba m by dabba y. Okay, so this is with respect to the y. So here I can write this is 4x, because with respect to the y Daba y by daba y is your 1. So you will get this one minus daba y, this one with respect to the y. So this is nothing but your 4y. Okay, where daba n by daba x. So this is also with respect to the x. So this is my 4y. Okay, this is independent of x, 0 minus with respect to the x. So here is 1, so minus 4y minus here is with respect to the x, so 4x. Now here is also minus 4x, here is also minus 4x, here is also minus 4x, here. So these two are equal. So daba m by daba y is equal to daba n by daba x. So this is an exactness condition is satisfied. Exactness condition is satisfied means df is 0. df is 0 means the given differential equation is your exact differential equation. So that I can write this is equal to 0. Okay. Now my next target is what? We want to find out a given function. What is your constant function? That is my aim. Okay. So now I know the m is what? M is equal to, so I'll write over here m is equal to daba f by daba x, that we know, total differentiation. So this term is daba f by daba x, which is equal to x square minus your 4xy minus your 2y square. Okay. Now my aim is to find out this particular function. So how we can find out that particular function? So we'll take this df over here. So this is daba f is equal to, this is x square minus your 4xy minus your 2y square, okay, into your daba x. Okay, so integral, so we can partial. So this is df, integration of your differential function daba f, which is equal to, this is integral x square minus your 4x. So I'll split up that particular term. So x square into your daba x minus, this is 4 is outside, y is also outside, so that here minus 2y square integral of your this. So we know integral of x square dx is nothing but what? X cube upon 3 plus constant of integration is c. Okay, minus here is your 4y, this is also x square by 2. Okay, this integral of x raised to n into dx, which is nothing but x raised to n plus 1 divided by n plus 1 into differentiation with respect to your d into dx. So that part you have already learned, so I will not go into the detail. X square by 2 minus 2y square into your x only plus constant of integration over here c. Okay, so this is a case. Now your aim to find out this particular constant c1. Okay, so in that case what I will do, I will get a given function. Okay, so there are two routes here. You can find out this constant of integration c1. One is your direct method and another is your indirect method. So I will go first is DTL method. So what I will do, this is my f. I will partiate the given function with respect to your y. Daba f by daba y. Okay, or I will write over here. Please don't. This is your daba f by daba y, which is equal to, this is independent of your y, 0. Here is, So you will get minus twice x square. Okay, here you will get minus 4 xy plus this c1 is a function of y only. Okay, the constant c1 is a function of only y, so partial differentiation with respect to your y, so that's why we have given c dash. But this is nothing but what? Dabba f by dabba y, which is equal to minus twice x into this one. This is equal to dabba f by dabba y. So that equation, if you remember here, we have n is equal to what? This is your y square minus your 4xy minus twice x square. Okay, so this is also dabba f by dabba y. So that will put over here. So this is y square minus your 4xy minus your twice x square. Okay, so using this is goes, this is also goes. Okay, and you will get the c1 dash, which is function of y, which is nothing but y square. Now my aim is what? We have to find out this c1y. Okay, that c1y, how will find out? I will integrate given function, because this is function of your dabba f by dabba y. Okay, c1 dash is nothing but your c1 dash is your y square is remaining only. So if you integrate, then you will get c1 of y, which is nothing but your y cube divided by this one. I will put that value over here. This is suppose equation 1. This is equation number 2. So automatically I will get, this is integrate and integration function. So this is nothing but what? c1 times y is nothing but integral of y square into your dabba y plus your c2. Okay, so this is my c2, constant of integration, and when you take an integration of a given function, so you will get this one plus. Okay, so put 2 in 1, because what value we have find out over here. So what I will get here, f is equal to x cube divided by 3 minus 2 x square y, okay, minus y 2y square x, okay, plus y cube divided by 3 plus your c2. But as you remember here, df is equal to 0. df equal to 0, so f is constant function. Okay, f is constant because this is differentiable, so that constant is suppose c3. Okay, so this is equal to your, the function is get, and that is equal to suppose c3. Okay, and that c3, c2 suppose it will become over here, and c3 minus c2 is, suppose I will consider c. So what function I will get over here? This is x cube divided by 3 minus twice x square y minus, so I can take common over here, suppose twice of xy. So what is remaining inside? Remaining inside is your x plus y. Okay, this one plus y cube divided by 3 is equal to c. Okay, so this is your constant function you will get. So question is very simple. You will get the case. What is my function? Function we have written over here. So this is my df I have given, x square minus 4xy, this function into dx plus this function into dy, and you want to check first is exactness, exact differential or not. So we have proved the first is dabba m by dabba y, which is equal to dabba n by dabba x. This condition we have proved. From that condition we have find out the df should be equal to 0. df is 0 means f is constant, that we have already get. This condition is satisfied means the given equation is your exact differential equation. So obviously df is 0, f is constant. Now next my aim is what? My aim is to find out the function f. So for that purpose what I have taken here? I have taken m is equal to del by f by del by x. Okay, which is given already. Okay, so my aim is find out f. F I want to find out, so I will dx I have taken over here, dx is taken over here. Now my aim is find out f, so I will integrate a partial differentiation and I will get this integration throughout this one plus constant of integration, suppose here is c1. So f is equal to, just we have taken the simple mathematics and I will get c1 times 1. Okay, now my aim is what? My aim is to find out c1. So in that case I have partiated this function f into your df, del by f by del by y is equal to, I will write this one. So once we will partiate with respect to the c1 is a function of y only, not your x. Suppose here you will get the c1 is a function of your x and y, that time given function is not your exact differential equation, or you can't find out the f in that case. So I will take one problem, so you will understood what I want to say over here. So this and del by n, this n is nothing but what? Del by f by del by y. So we have equate this term over here. So cancel the equal terms left and right hand side and I will get. Now aim is what? c1. So that we want to find out partial with respect to the, so again I have integrate the given function and I will get this particular value. That value I have put in equation number 1. Okay, and from that we have written this particular equation, f is equal to this one. But we know df is equal to 0, f is constant, that constant is c3. So this is equal to your c3. So c3 minus c2 I have written, suppose c, and I will get that function constant. So many times this question they will ask for 5 marks. So either you can do this way, this is your indirect method, so c1 is a function of your y1. Suppose you want to use indirect method here from this type. Okay, so that is very simple. So what is my first condition? I will again do the direct method. So this is my problem, x square minus your 4xy minus 2y square into dx plus y square minus your 4xy minus your 2x square into dy is equal to 0. So this is mdx. So we have proved this is del by m by del by y is equal to, so this is exact differential equation. From this step, so what is my solution? So this, remember the direct method. So f, function f, which is nothing but m time, if you remember the proof then you will understood this one, integral of m into dx plus this is integral term, okay, term of n, term of n not containing, term of n not containing the x into your dy. Okay, and that is equal to your constant function. F is your constant. So what is my m over here? M is simple, integral x square minus your 4xy minus your 2y square into your dx plus integral term of n. N is what? This is y square minus your 4xy minus your 2x square. 3 from x. So this is not free from x, this is not free from x. So free from x is only y square and into dy is equal to, suppose c, constant of integration. Okay, so the function is, or you can write only this much. Okay, so this is nothing but constant of integration. I will write over here is c1 or c. So this I will take the integral. So this is x square into dx minus 4y integral of your x times dx minus 2y square integral of your dx plus integral of y square into dy plus constant of integration. So you will get here x cube divided by 3 minus 4 y x square by 2, so minus 2y square, okay, into your x plus y cube divided by 3 plus constant of, so from here this is 2, so this is x cube divided by 3 minus sign I will take common, xy I will take common, so here x plus y plus y cube divided by 3 which is equal to, or this is plus c, and that is nothing but your constant. I will take that term over here, so basically you will get this is equal to constant. Okay, so if you compare this answer with earlier one, so you will get the same thing, only here you have to remember this thing. Okay, so plus constant of integration c, so m dx plus the integral, the term containing n, not term of n not containing x, dy plus c. Solve this particular problem, you will get the function. So previous one is indirect method, here you can see. So what is the necessary and sufficient condition? Please remember the statement, the necessary and sufficient condition for the differential equation m dx plus n dy equal to 0 is to be exact dA by m by dA by y is equal to dA by n by dA by x. So suppose someone asks the given function is exact or not, or given differential is exact or not, so prove this condition. And suppose they will say find out a given function and that should be always constant, so do this method or your earlier method. So this is basically your what we have learned today. We have learned the function and its derivative should be continuous, and second part we have seen one theorem. Proof is also we have seen, we have taken first is necessary condition and then we'll go to that particular thing, and that should be also continuous one, and we have seen one problem on the basis of this one. Please remember, if the function is not exact differential equation and you want to again find out the function f, so I will take a small problem so you will understood what I am to say over here. Okay, so in that case the problem is suppose only 3xy plus y square into your dx plus x square plus xy into dy. Okay, so check the condition first. What is condition? This is m dx plus your n dy, okay, which is equal to, so m is what? So dA by m by dA by y. So this is y is what? This is 3x, okay, plus twice of y. dA by n by dA by x, twice x plus y. See here, this and this is not same. So dA by m by dA by y, which is not equal to dA by n by dA by x, means this is not an exact differential equation. Still, suppose you want to find out f function from this particular theory. So how we can find out that particular case? So this is your dA by f by dA by x is what? 3xy plus your y square. Okay, I will use first method. So this is nothing but what? F is equal to this is integral. Okay, so this is your 3xy plus your y square into your dx. So you will get here plus constant of integration c1, and that is only y, function of y. So this is nothing but 3 x square y by 2. I will directly write over here xy plus your c1 times y. Now I will differentiate this with respect to the y again, because I am using a second method, by y suppose, and that is nothing but 3x square 3 by 2 into x plus your xy plus derivative of this one, which is equal to dou by f by dou y. This is dou by f by dou y, so that is x square plus your xy. Okay, so in this term, okay, c dash y is a function of y only. Here see, this will be cancelled, suppose. So c1 dash y, which is x square minus 3 by 2 x square y. The given term is not free from x. This is function of only y. But here you will get the term is what? If you remember earlier problem, I will get c1y is equal to y cube divided by 3. Okay, but that term is free from x, and this is function of y only. But in this case, this is function of your x and y, so I can't find out the function f using this particular method because c1. So this is not an exact differential condition, and still you want to find out the function. So that is not possible to find out, because whatever the constant is there, okay, which is function of your y, okay, so that should be free from x, and if that function is containing some x term, so you can't go for finding out that particular function. So this particular part we have seen over here. So what we have seen function and its derivative is continuous as well as so basically differentiation gives your continuity, and then we have seen the exact differentiation, the theorem, their proof. We have taken 2 problems to understood whatever everything. So thank you very much.